all know that all things we see every day are made up of the tiniest units called atoms. And these atoms serve as the building blocks of life on Earth and all the matter around the universe. So, what does an atom look like? Well, many scientists came up with experiments and theories on the structure of an atom. From Democritus and his ball-like structure of an atom, and other scientists and philosophers who came up with different models such as the plum pudding model of Thomson and the electron cloud model of Schrödinger. However, many theories were criticized and revised because they lacked proof and scientific explanations. And one of this model was the plum pudding model of J.J. Thomson that was rejected by Ernest Rutherford by his interpretation of the gold foil experiment by Geiger and Marsden that led to the creation of the planetary model of Ernest Rutherford. The Rutherford model is a model of the atom devised by Ernest Rutherford. Rutherford directed the famous Geiger-Marsden experiment in 1909, which suggested upon Rutherford's 1911 analysis that J.J. Thomson's plum pudding model of the atom was incorrect. In their experiment, they measured the scattering pattern of the alpha particles with a fluorescent screen. If Thomson's model were correct, the alpha particles would pass through the atomic structure of the foil unimpeded. However, they noted instead that while most shot straight through, some of them were scattered in various directions and some going back to the direction of the source. By the year 1911, physicist Ernest Rutherford proposed a model that the atom consisted of mostly empty space with all its positive charge concentrated in its center, in a very tiny volume that was surrounded by a cloud of electrons. This came to be known as the Rutherford model of an atom.
The model can be demonstrated as a planetary model where the positively charged center is the Sun, and the planets revolving in orbits around it serves as the electrons traveling around the center. This explains how the positively charged alpha particles in a gold foil experiment are being deflected by the positively charged nucleus, with some going through the electrons around the center. But the experiment has a few limitations, and Rutherford's experiment was unable to explain certain things. They are: 1. Rutherford's model was unable to explain the stability of an atom. According to Rutherford's postulate, electrons revolve at a very high speed around the nucleus of an atom in a fixed orbit. However, Maxwell explained accelerated charged particles release electromagnetic radiations. Therefore, electrons revolving around the nucleus will release electromagnetic radiation. Number 2. Orbits due to electronic motion will shrink and collapse in the nucleus. The orbits will shrink and collapse in the nucleus of an atom. According to the calculations, if Maxwell's explanation is followed, Rutherford's model will collapse within 10 to 8 seconds. Therefore, Rutherford's atomic model was not following Maxwell's theory, and it was not unable to explain an atom's stability. Number 3. No arrangement of electrons in orbit. Rutherford's theory was incomplete because he did not mention anything about the arrangement of electrons in the orbit. This is one of the major drawbacks of Rutherford's atomic model. But the Rutherford's model is unique among other models with different placements of the three fundamental particles of matter. But Rutherford's model is closely related to the quantized shell model of Niels Bohr, which is similar to the planetary model, but unlike Rutherford and its electrons traveling around at random, Bohr's model consists of a positively charged nucleus surrounded by electrons traveling at arranged circular orbits, which is another topic to be discussed by the neighboring group.
Reaction ni Kim niya, reaction ni Kim.
Base, redo, doan dito, kang nga nakamayo.
Hindi mo tingin din yung pag-iyo.
Kita ko